All right. Yeah, I am going to talk about biometrics for research software and how and what are the plans for the university. Also, on behalf of a lot of amazing job that has been done for the FAIRS, for research software working group. There's a lot of people involved that I could take the whole hour mentioning everyone. So let me start with a story, right? So a couple of months ago, there was a new breakout of monkeypox variations, right? And different governments needed to recognize where is this happening and so on. Fast forward, news outlets, they actually recognize and acknowledge that international cohorts of scientists are putting a lot of efforts to annotate these genetic variations in phylogenetic trees in all the fields of epidemiology, really. But how do they do that? Right. So this is a research software story. So they do that using this platform. It's called NextStrain. This platform is a real-time tracking of pathogen evolution. It's one of the most popular platforms in what do you say? Epidemiology. Thank you. And it's actually doing this for a couple of years already with different type of diseases, right? So this type of platforms also got very popular because it helped the international scientists on annotating the variations of COVID, right? So it's a platform for scientific collaboration. The code is open source. It won an Open Science Prize, the American one, in 2017, and it actually openly shares the annotations among international groups, research groups. But it's also a bioinformatics toolkit and visualization written in JavaScript and Python. It is actually recommended by the World Health Organization. So, and it all, this very beautiful, the visualization part, you could see that, for example, in COVID times, how the research group were actually starting to annotate the different variations in time, right? And here's the point that I want to make. So research software, all these things, so this platform, it's a web service. This platform is annotation, it's collaboration and annotation. It's a database. It's a website. It's toolkit. It's all that. It's research software. So then it brings me to the following questions. Is research software so important for science? Kind of what are we doing? So I'm going to talk about metrics and some of the plans that we have. But before we got into the detail, let's kind of agree and review what is the definition of research software, right? So according to the Fair for Software Research Data Alliance definition, it's any source code, algorithms, script, computational program, really any executable that is created for research purposes or in the process of doing research, right? So this includes, of course, scientific code that we are normally used to, R, MATLAB for our analysis, also includes any computer programs, Jupyter notebooks, or web services that are developed on JavaScript, whatever. But also includes applications, file scripts, SPSS, and all that, right? So it is an umbrella term for all those executable computer programs. So it do not discriminate, right? But very important to note that research software is a digital object, so that's why it's different from data, because by itself can be described as metadata and can be deposited on the repositories. And each one of those digital objects has persistent identifiers, as you can see. We can go actually very philosophical, whether if software is a type of data is a type of software. But in a very practical terms, also from the legal side, software is the result of a creative work, right? So therefore, it can be copyrighted, and normally it concerns intellectual property rights and product liability rights. whereas data has to do with other type of legal frameworks, and data are facts, not creative work. It can be obviously open source or proprietary. This digital object is executable, and obviously degrades with time, and that doesn't happen with data. Technology is evolved, and if the software is static, it immediately degrades by definition. So, okay, now that we took away the definition, what are the developments on fair use software? Not so many years ago, just like what happened with the good old FAIR principles, also people, they gather in workshop discussions, and they also decided that, you know what, as this digital object also needs a particular implementation of how we look at the FAIR principles, because it has different characteristics and different liabilities. The Netherlands eScience Centers is one of the most important hubs for research software. They have already done a lot of practices on how to deal with software management. Therefore, they launched the 5 recommendations for FAIR software, which was a very initial stepping stone. Those people, they got together in these workshop discussions, and then they came up with a seminal paper towards FAIR principles for research software. These very amazing people started to work together, and then they basically joined forces with international communities, Research Software Alliance, and so on. And since 2020, there is a huge working group on FAIR for research software. More recently, this year, after 1 year of reviews all over the world, how now we have the implementation and the recommendations for FAIR for research software. What we're going to try to do here at the university is an interpretation, or how they call it in law, a transposition of those international rules and norms and recommendations to how they look locally, right? So the original team for FAIR for research software, these amazing people working on it, they had these 4 aims: to bring up some candidate metrics of what can it work for research software. They prototyped some of those metrics. They evaluated somehow with the sources they have, and then they set up the recommendations. Now, this project was actually funded by the Open Science Fund 2 years ago, and that's how it came, all the working group and so on. More recently, we at the University Library, we're being involved slowly. And then also some other stakeholders started to get engaged and start to, promote and say, okay, this is really the way to go, and we can take all the learned lessons that we have from FAIR data and kind of speed things a little bit on the software agenda as well. Right. So what are, kind of how we can look at these FAIR principles applied to software? It is more or less straightforward to looking at them, because we have to only take in consideration what we know already about the FAIR principles, like, for example, metadata description, DOIs, terms of use, interoperable formats, all those things that we already know. But then we combine them with existing practices for open source development, right? So FAIR research software is more or less, a combination of these practices, plus other things that we're gonna look into. One second. So what are some practices on the open source development? Like you have provenance of release notes, you have provenance on things related to security checks. There are some things related to systems quality, and there's actually a long list. And there are as of today, a couple of frameworks that are dealing with implementing those metrics on a quantitative way. These are really great initiatives, like the FAIR recommendation that I already mentioned, the Barcelona Computing Center. They have the FAIR soft approach. Here at the Institute of Data Science, together with Freie Universiteit and the Science Center, they have created also the FAIR workflows tool. Not necessarily gives metrics, but somehow in the same lines. I'm going to give examples of these two. Now, one of these tools for creating these fair metrics is called howfairis. Howfairis is a Python package, so it's a research software that evaluates research softwares, right? It can actually evaluate itself, right? So that's cool. So, and it's kind of a checklist, really. And this checklist basically complies or tries to implement the 5 recommendations, right? You have the code in a community repository. Have you assigned a license? Is it in a community registry? If it's a JavaScript code, is it on npm? If it's an R code, is it on rcran? If it's a Python, it's in PyPy, right? Have you assigned an identifier for easy citation? And then you get this checklist of the OpenSSF best practices. You tick the boxes, you get a badge, 5 out of 5. There we go. You can check at the repository. It's really straightforward to implement, right? So in a collaboratory notebook in Google, 1 line of code, you put your repo to get your result. Binary assessment, you get a score, and was developed by the Netherlands eScience Center 2 years ago. Now, since it's Python package, it really has an API, then you can ask the question as a developer, oh, well, can we just assess many at once, right? Actually, we can. The Utrecht University Library, they created SWORDS, the Scan and Review Open Research Data and Software. And basically what it does is tries to map the people from the university with projects that are publicly available on GitHub and GitLab, match them, and goes and screens all the scores for all those projects. Not surprisingly, we can see that the majority of the cases, they were scoring like 1 or 2 of the 5 checklist thing. Majority of the cases. 142 users, more than 1,000 repositories. Now, we have a fork at the Maastricht University Library repository, but then it was a little bit tricky because to implement it, you need to map personal data with public project repositories. And GitHub is not an institutional tool, so if it was everything inside Maastricht University, wouldn't be a problem. But then you are dealing with personal data processing, and then we need consent of people basically. So still on there, trying to figure out how we do it here. Another one very interesting from Barcelona Supercomputer Center. They tried to map the FAIR for research software indicators that was already recommended by Research Software Alliance into kind of a scoring system. Again, it's a binary choice where if you contain or you're able to do this or not with software, and then they assign a score. Now, the score is weighted with the high level and low level indicator. But to give you an example, they also screened and they tested the FAIRsoft with all open instances from Open eBench platform from Elixir. More than 43,000 tools were tested that are in that registry. And you would get things like, for example, is it an existence of a downloadable and buildable working environment? We can see it's very spread out. 1 out of 4 projects were, just scoring 60% somehow with the FAIR principles. 1 out of 5 were not really scoring well. Another example with interoperability, it varies basically as a question. So, are there documentation on the data types, data formats? Majority of the cases, not really. So yeah, that's also a very nice approach. I would argue though that with this low score and high score levels kind of thingy. It is very handcrafted, I would say. Uh, the score system goes from 0 to 1, and it's so handcrafted that actually it can vary depending on the impact of the field of those research software thingies. So that also have my question marks, but it's good that we are already there are some initiatives and are already tested. Now beyond kind of the fair checklist and all those things, what about impact, right? So impact in the positive sense, like can we actually measure positive impact? Like for example, you have something in these repositories that is popularity. You get stars, you get forks, people watch your project. Can we take that into account? But also negative impact, like for example, if your research software is on the blacklist of security risk dependencies, well, that's actually doesn't seem very good. But also environmental impact, maybe. This is a very interesting project on the machine learning carbon footprint, where you basically give indications of what type of hardware, hours used, the provider you have, and all these type of variables, and you get a score on how much are you emitting, and kind of how responsible are you using your computational means. If we're going to start to look at impact, then I would like to ask, how can we translate this research software impact into recognition and rewards, and all these fair metrics and research software impact, what this metric has to do with it? They are very interesting things to take into consideration. So then I go back to the question, so if research software is so important in science, we already saw that, yeah, can be fair. There's a lot of challenges. And we only saw the quantitative side of fair. But then this part, how it's managed and sustained, and what are the incentives we saw in the last slide, this goes on the organizational level, right? So yeah, we can measure things, but to actually take care of answering these questions, we need to look inside as well. One of the things that we want to work on is on a roadmap. Let's try to aim for 2 years work, 2 years roadmap, where we have 4 components: engagement, policy and communication, use cases, and community-driven development. I mean with engagement to try to strengthen the connections that we already have, right? If we have a central coordination for research software agenda, we can strengthen the links that the national effort that we already mentioned with research software hubs, and that the faculties have already with local communities, like for example, MEMIC, the AI Club, and all these type of research software clubs that are around the DSRI community. We strengthen those links, and then we basically make accessible this capacity for the local communities, and also things like, for example, the new investment that is coming from the thematic DCCs and the research software engineers that are coming to the thematic DCCs. They are appointed quite some FTEs on the national level, so that the faculties can actually get a grip on it, right? So that's why we kind of need a research software agenda. Did I do something wrong? Yeah. In the side of policy and communication, well, also can be really straightforward. We only need to embed to existing efforts. So we have already the open science policy, we have the fair action plans, we are creating the roadmap for our research infrastructure at FSC, but also we can include on the faculty workflows, right? All those recommendations, we do amendments on existing frameworks. The same with existing portals. We only need a new research software management section in the RDM portal. We need some updates on the DSRI community and the open science community, but also on the Maastricht University portal. In the use cases side, obviously what we want is to get, strengthen those connections that we already talked about and have the faculties excited as well. But also the service centers are doing some work on that. As Carlos mentioned before, the first conference on fair digital objects is coming, and it's very important to put also our work in there. So one of the things that we're going to present together with this brilliant guy, Vincent here, is the fair extension. So nothing too complicated, really. It's just a browser extension. Just a browser extension. But that is connected to one of the fair evaluators APIs, right? In this case, we're going to test it on fair enough from all the fair evaluators. So that if you are on a scholarly aggregator, like your pure system or in Google Scholar, Semantic Scholar, whatever, you can get fair indicators in your user interface, really. So it's more like bringing fair to the researcher instead of the researcher goes to fair, right? Then you get those indicators based on your digital object identifiers, on your DOIs, whether if it's a poster, a book, a data set, a software. You will get everything on the browser extension. We have already a demo. You can go to the GitHub link. You need to manually install it. It's not yet on the Chrome store. Hopefully, we have it on the Chrome store by the conference. So let's see. Finally, and a very interesting and important for all of us, how is this community-driven development is going to work out, right? Also thinking of, I myself work on development side, Carlos, Vincent. So there's really a network of people that are dealing and doing research software, but then somehow we need to, kind of go back to our work. And it feels wrong, right? Because research software, it's also our work. So first we list and make an inventorization of what are the capabilities for research software management, like software management plans, workshops and trainings, cloud web services, education, high performance computing education, all security protocols education that we can recycle from the security services of Maastricht University, fair software archival, and all those things that we already talked about, and especially just software development. Right? We identify where the experts. The experts can be external, like for example, carpenters, trainers, or there are literally 80 research software engineers at the eScience Center. And many of those, they are literally waiting for work. So it's crazy. We have internal communities that also do this type of work. We just want to be recognized and we just want to, work together. That's why where the research software agenda come in. And a little teaser, what we want to create is a hub for this knowledge, right? So the Maastricht Research Software Hub, and hopefully we get things running and update the existing policies at the university. So the takeaway, research software is important and it's an inherent part of the research lifecycle. Therefore, fair, and I would add this part, fair and sustainable software contributes to open science. There are some initial efforts to try to measure the impact and how to implement fair metrics. Still, they're all actionable checklists, just checklist. Checklist, I don't know about checklist, but well, it's a start. Research software management is a community effort. We see already the open source community. You don't do this alone. And a fair software agenda was presented. Thank you very much. Thank you.
Yeah, I think that it's time for questions. Thank you so much, Pedro. I'm gonna prioritize here. Anybody want to ask question, comment, suggestion?
I have a question then. Maybe I can kick it off.
Yeah.
So fair data This is fair software, but start with fair data. One of the things we see, it's very technical, and it's very difficult to convince clinicians that working with data is a lot of fun and that they have to make it fair. Right? So it's a big barrier with fair software. That problem is sort of gone because the people that work with it are very technical. So my question is, you have experience with both being like a data steward and also what can fair data learn from fair software? If we take out the technical barrier, what's the next barrier? What can we learn?
Yeah, that's a very good philosophical point of view. Yeah, I guess the future will come to us at some point. So that means that things that we're trying to figure out how to help making reuse of data, that will come along because that will be facilitated by tools. Right now, there is a lot of pilots on how to do interoperable formats. There is a lot of knowledge bases of how to reuse data. I'm really positive that in somehow, sometime, that barrier will be filled with technologies, right? Still, that's only on the technological side that will be solved at some point in the future. But then we have to still see the principles you just started mentioning. The FAIR are very technical, and I'm like, question mark. FAIR are principles, and are really timeless, and are really these are like beyond the normatives. It's like going to the French code of in the law. You have the principles of légalité, liberté, égalité, et fraternité. So it doesn't have to do with anything technical or how it's implemented. Those are the principles that by principle I make my data findable. So that's more or less. We have to go to the core and what my principle at home is to separate the waste in plastic and paper. How do I do it? That's something else. But the principle of that I want to do it, that's what we want to change.
If you want people to do it, you need to tell them how they should do it. And this is, in my opinion, this is what is really missing from fair data, wherever it's for fair data for data or fair data for software. The only difference, because if I look at the publication that was done in May 2022 about fair research software, they just restate the FAIR principles without giving any guidelines. And to me, it's a bit, if you say anyone, all you researchers are working on your research and you don't want to do research on how to publish your FAIR data. So this should be pre-done by the institution who are asking you to make your data fair. Because now institutions are asking, can you make your data fair? But then they don't even tell you, not only they don't give you tools to do it, but they don't even tell you what is a fair data. You have the fair cookbook. Good luck. Even me, I've been working with fair data for years. I'm not going to. It's a lot of smart thing and well-built thing, but it's really for research, fairs researchers. And the only thing is here the guys from like you say, they're more technical. So, but if you look at it, the fair howfairis is a really simple package. It just checks your GitHub URL. It's going to check in the README, do you have a badge that points to a Zenodo thing? It's not that, they don't even query an API to check for a Zenodo thing. It's really basic, but at least, it gives the tool. So maybe, trying to think, first having more clear what is fair, how do I make my data fair? Because even fair researchers don't really know.
Yeah.
If you ask to the people who created FAIR, how do I make my data fair? You have 2 days of discussion, and but it depends on your community. You need to first gather all your community and this. And we miss a bit some really practical, technical overall the guidelines. Like howfairis, I think really did it well because they would say, okay, 5 steps, really simple and really important. The license, and then they point to something that is much more technical, like the infrastructure for best practice that you need to fill up. That is much longer, but but at least they say, okay, this is how we do FAIR. And the problem is in a lot of cases we don't. No one's. I guess it's hard to say.
Yeah.
If you say this is how to do it, then you need to also build the tools to do it.
Yeah. I mean, I do take that message that we are missing the part of the how, really the how and the means. I mean, really coming back to my example of speaking ways, it's like the government tells me, okay, now we're gonna, you're gonna get fined if you don't split your trash. Okay, fine. How do I do it? Right. So you need communication channels. You need agreements like, okay, so here are the type of cans that you can use, green, blah blah blah, blah, right? So it's yeah. I guess we really need to sit down, communities, and say, okay, let's take this seriously. Like I don't do it just for for a requirement. We as community, we just sit together and say these are principles. Like is the principle of splitting my waste in green and not green. Well, the principle of by default creating my data findable and reusable.
I had a question for Pedro. Can you hear me?
Yeah, I can hear you.
Okay. Yeah, no, first of all, I wanted to say that I think a lot of the job of the data stewards has also been trying to translate this FAIR principles into trainings, where researchers really, get at least some general guidelines about how to do FAIR. So that's also like a little commercial for our upcoming FAIR Essentials training. And secondly, Pedro, my question was, do you think that in the future, this FAIR metrics will allow us to evaluate like how scientific data is being democratized? For example, how much is it being used in the world by others? Like, for example, scientific data coming from the Netherlands, is it being used in other countries? Or how that was a question that was asked to me by a student yesterday at FASOS. So he said, how can we evaluate that FAIR is really making knowledge democratic? Or yeah. Thank you.
Absolutely. Really coming back to the thank you, Maria. I mean, like to everyone that has not done the FAIR Essentials should do it. That's on one side. On the other side, going back to the first slide of the COVID, if you really recognize those researchers and developers that put those tools on, on the desk and say, okay, let's try to annotate variations of diseases, it actually saves lives, right? So if you, as a developer, that created a tool that actually saves lives, I'm gonna lose my job next year. What am I doing? So that's something we really need to consider. Yeah, I hope we embed these efforts into actual recognitions and rewards actions as well.
Yeah.
More practical question: have you considered the impact of different languages on how you measure your FAIR metrics? Because if you write something in a particular language, it may be very easy to extend that language, or it may be that program, or it may be a lot more difficult. Like, to give a very simple example, in Python, everything is dynamically typed. You don't know what this variable is. You need documentation.
You can put type annotation.
You can, but who does that?
I do.
Congratulations.
Saving saving Python.
Some people do that.
No, but I get the point.
Has an influence on how you measure whether or not this code is reusable or not, or well, easily reusable.
Yeah, but Python is so much more reusable than Java if you compare. It depends on the size of your software.
What you want to do, but
yeah, exactly. And I think that's a great point, because that's one of the differences with data, that one of the aims of making data fair is to be reused, right? But with software, it goes really beyond the reuse, because you have three things. You have the use of users, like using the program, but you have the reuse of developers that can reuse components of that code. You already have two types. And then totally forgot the third thing I wanted to say, the impact, right? So that the impact that this software tool is doing, it's bringing community together. Is it downloaded by 100,000 people in this sector of the world? So you already have three different aims that they were not occurring on data. And I would say that if you look at the code or at the software from a digital object perspective, it makes a lot of sense because you only care about the digital object, not what was inside, let's say. So you describe what it is, what it does, when it was created, what are the versions, what are the dependencies, and you are describing the thing. So it's really agnostic of whether it's a programming language that you created yourself.
I think it's really pertinent for things like MATLAB, or I mean, in this case, it's really hard to reuse because then you need a license. And I don't know if they.
That's also affected. Do you need licenses for this language, or is it an old? I don't know. Maybe someone wrote something really good in Fortran. Good luck finding someone who can extend it.
Technically, if you build the repository and if you provide the right license for your code, it should comply with the license of the language, I guess.
Yeah.
By just getting the license of your code, it should be enough. But yeah.
That's why I want to not just talk about fair, because I think for software is not enough fair. That's why we have to think also sustainability and impact. Because I can have the most fair machine learning algorithm, but it's killing a lot of trees. So so I don't know. So it's sustainability and impact, I think, are also part of the equation in software. And one of the points that you're making is like, okay, how to trace these contributions and how to actually make better software, secure and reliable. In data stewards, we're helping like things like, okay, for data management plan and something like this. Kind of a one-go help. But that's why in software, we need research software engineers that can be all along the project. Right, so they are not really. They should be more project dependent, right? So one research software engineer for just a number of projects, right? So that they understand the code and can comply and then make it secure and all that. That's really different than with data. So yeah, we need to think about engineers research. Thank you.
Want to learn more about the open science movement and FAIR? Find our next events below.